Hello everyone. So we have another academic video for your reference. So in this video, we will begin module 2 of software engineering, which focuses on requirement engineering. So before building any software system, the most important question developers must answer is what exactly should the software do, right? Requirement engineering helps us clearly understand and document those expectations before the development begins. Okay, so here what will you learn? I have module wise, syllabus wise listed the topics. So here we'll explore the concept of requirement engineering and understand why it is critical in software development. So we will learn different requirement elicitation techniques which help gather information from the users as well as all the stakeholders. We will also differentiate between functional requirements and non-functional requirements. Then we will understand the software requirement specification document, commonly known as SRS, which formally records all system requirements, as we all know. Finally, we'll also look at best practices and challenges in managing software requirements. So what is requirement engineering? So requirement engineering is the systematic process of identifying, analyzing, documenting, and validating the needs of stakeholders. Okay, that is a definition per se for the exam. So in simple words, it answers the question, what should be built? So before developers start coding, they must clearly understand what users expect from the system, right? So requirements engineering forms the foundation for design, coding, testing, and maintenance. If requirements are incorrect or unclear, the entire software project may fail. Why requirement engineering matters? So requirement engineering is extremely important for several reasons. First, it helps prevent project failure because many software failures occur due to unclear requirements. Second, it helps reduce costs because fixing requirement mistakes later in development can turn out to be very expensive. Third, it helps save development time since clear requirements will reduce rework. Finally, it helps align all stakeholders. Who are the stakeholders? Including developers, testers, managers, clients, etc. Understanding requirements. In software engineering, requirements are generally divided into two major categories, functional requirements and non-functional requirements. So basically understanding the difference between these two types is very important during system development. So functional versus non-functional requirements. So functional requirements, as the name implies, describes what the system should do. For example, suppose the system should allow users to register. The system should generate reports. Users should be able to search data, etc. Non-functional requirements describe how well the system performs its functions. Examples include performance, security, usability, reliability, etc. So I've listed what it is. You can just have a look. For instance, a system may require that login should complete within 2 seconds. Okay, so something like that. So now we'll have a visual comparison. So let's compare them again. So functional requirements focuses on features and operations. They define what services the system will provide, and non-functional requirements will focus on system quality and performance, and they will define how well those services operate. And both are essential for designing a reliable software system. Requirement elicitation. So requirement elicitation is the process of gathering requirements from various stakeholders. We have seen who the stakeholders are. Who were the stakeholders? If you remember, they may include users, clients, developers, project managers, etc. This stage is extremely important because it helps developers understand real user needs before development begins. So requirement elicitation versus requirement engineering is what we are going to see here. So requirement elicitation is only one part of requirement engineering. So which one is the broader concept? Obviously requirement engineering. Requirement engineering includes the entire process of handling requirements, including elicitation, which we are comparing right now, analysis, specification, and validation. Requirement elicitation specifically focuses on collecting information from users and stakeholders. Very small part. So the techniques for requirement elicitation. So there are several techniques used to gather requirements. One common technique is interviews, where developers directly interact with stakeholders. Another technique is questionnaires, which is basically useful for collecting information from many users. So we just send the questionnaires to how many of our users we need, they fill it and send it back. Observation is another technique where developers watch in the real-time scenario how users perform tasks. Brainstorming sessions help generate creative ideas. So now techniques in detail. Let's briefly understand some of the techniques in detail. So interviews, as we said, allows developers to gather detailed information and clarify requirements because it's a two-way dialogue. Questionnaires help collect structured information from a very large number of users. Observation helps identify real workflows and hidden problems that users may not describe. Each technique helps developers gain better understanding of system requirements. Now we have an activity which actually you can keep as a reference while writing examples. Let's consider a simple activity. Imagine developing a mobile application for college students. So try to identify at least 3 functional requirements and 3 non-functional requirements for this application. So now think about what students would expect from such a system. Keep thinking. For example, functional requirements could include viewing, class timetables, schedules, etc., or downloading lecture notes, or checking attendance records, and so on. Non-functional requirements may include maybe the pages when they check should load fast, like fast loading pages. Then secure login systems. Then they may need mobile-friendly user interfaces, etc. This example shows how both type of requirements are necessary we design while we design a real application. So moving to the SRS documentation. Okay. So the software requirement specification, or SRS, is a formal document that describes all system requirements. So it basically acts as an agreement between stakeholders and the development team. So SRS also serves as a design reference, a testing guide, and a planning tool for the project. So it helps estimate project cost and schedule more accurately. So now moving to the purpose of this particular SRS document. So this document has several purposes. It provides complete documentation of the system. It helps communicate requirements clearly among stakeholders. And it also provides legal protection since it acts as a formal agreement between the client and the development team. So now what can be the contents of an SRS document? A typical SRS document includes so many sections. So we have to start with an introduction which will describe the purpose and scope. And the overall description will explain system characteristics. The functional requirement, as we know, will describe system features. And the non-functional requirements will define system performance and constraints. We've seen examples, right? And finally, the assumptions and limitations are also documented. Now the SRS structure. So in general, the SRS structure can be divided into sections. The first section includes introduction and system overview. The second section describes functional and non-functional requirements. And the final section describes constraints, assumptions, and additional references. This is how it is structured. Okay. Now, taking a real life analogy, requirements engineering can be compared to building construction. How? Now, constructing a house without a blueprint would create confusion and errors, right? Similarly, building a software without clear requirements can lead to very poor results. So clear requirements act as a foundation for successful software development. So the cost of fixing errors actually, as you can see, increases dramatically as the project will progress. If requirement mistakes are discovered during later stages like testing or deployment, fixing them becomes extremely expensive. Therefore, investing time in proper requirement engineering saves both time and money. That is what this depicts. Moving to best practices, there are several best practices in requirements engineering. First, involve all stakeholders from the beginning. Second, document requirements very clearly. Third, validate requirements regularly. Fourth, prioritize requirements based on importance. And finally, manage requirement changes systematically. So now, getting into common challenges. Requirement engineering also faces several challenges. Like sometimes stakeholders cannot clearly express their needs, right? So requirements may change during development. Different stakeholders may have conflicting priorities, and communication gaps between the technical and non-technical teams may create misunderstanding. So these are common challenges which you should know. Now let's summarize the important points. Requirement engineering defines what should be built. Functional requirements describe what the system does. Non-functional requirements describe how well the system performs. Requirement elicitation techniques help gather information from users. And the SRS document acts as the backbone of successful software development. So now I have an assignment here, like which we've already discussed and done. So the how an online food ordering system works. So I have asked you to list 5 functional and 5 non-functional requirements for this, considering certain aspects. And also I have given the interview questions, prepare 5 interview questions to gather requirements from the users of this food ordering system.